Today we're going to cover section 5.6, and we're going to cover half of 5.6 today and the other half tomorrow. I'm going to start off by saying when we have the quadratic formula, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's quadratic formula. In every problem that you did in your homework last night, or whenever it was that you did it, underneath the radical, underneath the square root, you should have got a positive number. Is that true? Right. And so that underneath the square root, which is b squared minus 4ac, that was always a positive number. And how many answers would you get? You got two, the plus or minus, right? Remember I said when you have a parabola and it comes down and it touches and it goes right back up? And I think it was -2. How many answers does that have? That's one, okay? So, I think we can say, by the way, this b squared minus 4ac, this part of it, the b squared minus 4ac, thank you. All right, and that is called the discriminant. There's a name for that underneath the radical, and it's called the discriminant. So if the discriminant, if b squared minus 4ac is greater than 0, which are all the ones you had in your homework, then we have two real solutions. Okay. Let's take an equation, x squared plus 4x plus 4 equals 0. That was the one I did earlier where if we factored it, it was x plus 2, x plus 2. Let's use a quadratic formula to solve because it will work for everything. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Or 2 times 1, which is just 2. Okay? Can you tell me what we're going to have, what my discriminant is going to be? What number I'm going to get underneath the radical? 0. So I'm just going to have -4 plus or minus 0 over 2, which is -2. Okay? So we can conclude that if the discriminant, if b squared minus 4ac, if what's underneath the square root is equal to 0, then how many solutions do I have? One. I have one real solution. Okay. Well, what if the discriminant, there's one other possibility, if the discriminant is less than 0, if we get a negative number, how many real solutions do we have? 0. We have, then there are no real solutions. We have a parabola. And what can you tell me about the parabola that has no real solutions? It doesn't hit the x-axis. It's up in one of the quadrants, or maybe it's below. It doesn't mean that it doesn't have solutions. It does have solutions, but they're not real. I know. And just in time for Christmas, we have something called imaginary numbers. I didn't say he wasn't. I did not say Santa Claus is not real. All I said was just in time for Christmas, we have something called imaginary numbers. And a better name for imaginary numbers is the complex number system. It's a complex number. I don't like the word imaginary, but we're stuck with it. Remember I gave you the flow chart of the real numbers? And I said we broke this down into rational and irrational. Remember that? And then underneath rational, we had integers. We had whole numbers, we had natural numbers. We had this flow chart. But real numbers is not the only number system that we have. We also have complex number systems that include real numbers, but it also includes imaginary numbers. And what imaginary numbers allow us to do is to take the square root of a negative number. For instance, if I ask you to find square root of -3, we can write that simply as it's I square root of 3, I standing for imaginary. And what is I? I is the square root of a negative number. It's square root of -1. That's what I is. Don't change the I to the square root of a -1. I is simply I. But this is what it means. And so let's use a little bit of math. What is I squared? If I is the square root of -1, what would I squared equal? -1. Right? And we'll stop there with the i's. Okay? Let's take an equation that looks like x squared plus 16 equals 0. Does it factor?
Yeah.
No. It will factor if it was x squared minus 16, the difference of two squares, but I can't factor the sum of two squares.
Yeah.
So let's solve it this way by subtracting 16 from each side, and then square root. X is equal to, what's the first thing I write? Plus or minus. Well, what's the square root of 16? 4, right? Square root of 16 is 4. And the square root of a negative is I. So I can write this as plus or minus 4i. Okay? When you have the square root of a negative, we can bring that outside the square root and make it an I. Read.
Since we have it's plus or minus the square root of -16, why does that matter if there's a negative in the square root if you can add that or subtract it anyway? Because I feel like the negative in the front kind of accounts for the.
No, it doesn't. The negative just accounts for a root. The negative right here you're talking about?
Yeah.
That just accounts for the root. The negative inside accounts for the I.
Oh.
It's not a double negative.
Okay.
Okay? What's your question, Will?
Would that be 4i squared?
Nope.
Why would it be just 4i? Because
The square root of a negative is I, and the square root of 16 is 4.
I'll pick
Okay?
it up.
We haven't dealt with the I squared yet. Let's see how it might work in an equation. Here's a function, f of x equals x squared plus 3x plus 8. I know it doesn't factor. For whatever reason, I don't want to complete the square. So let's put this in the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, 2 times 1. The only time that you should use your calculator if you need to is to find what's inside the square root. I don't think in this problem we really need to. 9 minus 4 times 1 times 8. Well, 9 minus 32 is 23, negative 23. So x is equal to -3 plus or minus. The discriminant is -23 all over 2. So the solution, what x is equal to, is -3 plus or minus I square root of 23. That's not a perfect square. 23 is not, so I have to leave that inside, all over 2. Those are the zeros. If you were to plug -3 plus I square root of 23 over 2 into this equation, it will equal 0. And if I put -3 minus I square root of 23 over 2 in this equation for x, this equation will equal 0. And if I have time tomorrow, I'll show you why that is true. All right? We're not going to be able to really grasp all of the ins and outs about imaginary numbers. Okay, we're just going to touch on it. Just understand the math on it, all right, for right now. Imaginary numbers. Okay, let's take another example. Let's take, I don't know, 6i squared. Simplify. What is 6 squared?
36.
36. I is going to act just like a variable. If that were 6x in parentheses squared, wouldn't it equal 36x squared? So this would equal 36i squared. And if you remember from the previous screen, what does I squared equal? -1. And 36 times -1. So 6i squared is -36. I acts as a variable. So you're going to see problems 3 plus 2i plus 7 plus 5i. And if the I acts as a variable, which it does, we can just combine like terms. 3 plus 7 is 10, and 2i plus 5i is 7i. This is how I write a complex number. The 10 is the real part. The 7i is the imaginary part. Every number can be written as a complex number because every number is complex. We have the real and imaginary. I can write the number 9 as a complex number. 9 plus 0i. A complex number can be written as a plus bi, where a is the real part, and this is the imaginary. Here's and problem, write 9 as a complex number, 9 plus 0i. That's simply 9. How could I write 6i as a complex number? 0 plus 6i. Okay? Every number can be written as a complex number. Okay? We're going to do just partial homework tonight. I want to make sure that you guys get every single problem done. All right? On page 320, problems 14 through 41 all. And make sure you get that homework done tonight, please. All right? It'll make tomorrow's work go so much easier. Okay, that's it for today.